All right, so in this module, we're going to go over an example of a question using the steel phase diagram or iron carbide phase diagram. All right, so just as before, this is going to appear on the quiz. And so I'm going to read off the instructions here, pause the video, and then go over to the quiz, try to answer it, and then come back and we'll work this one together. All right, so this one actually has a number of parts here, but what I want you to do is consider a steel alloy, which has 99.6 weight percent iron and 0.4 weight percent carbon. And I want you to consider this at a temperature just below the eutectoid. And so I'll put the picture of the phase diagram so you can see it, or it's also in your book if you want a bigger view of that. And what I want you to answer about that alloy at that temperature is the following things. First, I want you to determine the compositions of cementite and ferrite, so Fe3C and alpha. Next, I want you to determine the amount of cementite in grams that forms in 100 grams of steel. And then lastly, I want you to determine the amounts of perlite and proeutectoid ferrite, alpha, in 100 grams of the steel. So 3 questions here. See if you can answer those, and then come back and we'll work this one together part by part. All right, so I've tried to replicate the iron carbide system here. Probably not super well, but a couple things to note. I haven't really drawn the top part, so really we're just going to focus on the eutectoid, which is at 0.76, and then we have a composition of 0.4, which puts us over here roughly, and then this is the eutectoid at 727, and we have cementite at 6.7 weight percent carbon, and then the max solubility at the eutectoid of alpha, which is over here, of 0.022. So this is alpha phase over here. This is alpha plus Fe3C. This is gamma. This is alpha plus gamma. And this is gamma plus Fe3C, just to kind of complete the phase fields that we have. So part A is basically asking us for the compositions of Fe3C and alpha. So we're looking for C Fe3C and C alpha. So, and the question tells us we're at a temperature just below the eutectoid, so just below 727. And so that would mean that we're basically right here, that little dot. So at that dot, how we do compositions is just like we've done in any other phase diagram, right? We draw the tie line. So I'm going to switch to maybe red actually would be better. And I'm going to draw the tie line at that point and at that temperature. Right? And so when I say just below, it basically means right at 727, but just underneath the line. And so I tend to exaggerate it a little bit so that you can see that, right? So our compositions are at the endpoints, right? So we have a composition there and there because this is our two-phase field. And this point right here is C alpha because we're right next to the phase field for alpha. And then over here, this is our composition of Fe3C, right? So the composition of Fe3C doesn't change. So that is 6.7 weight percent carbon. And then alpha, which is over here, since we're just below 727, it's our maximum solubility of carbon, which is 0.022. So C alpha is 0.022 weight percent carbon. So it's very close to pure iron, but has a small amount of carbon. And then Fe3C has the same composition, and so it's just a fixed composition, which is this line of 6.7. All right, so that is part A. So for B, it was asking us the amount of cementite that forms in 100 grams. So we've already done weight fractions, and the only additional thing is it wants the weight fraction of cementite, so Fe3C, but really it wants the weight out of 100 grams of steel. So since we know the fraction, we know we have 100 grams, we can just multiply that by 100. Okay, so if cementite is a phase, right, and we want to know at this temperature, which we've already drawn, the red line, right, how much cementite we have, we're just going to apply the lever rule, right? That's all it is. And we know that the weight fraction of Fe3C, when we look at the lever rule, since the composition of cementite is over here, we're going to take the opposite section compared to our alloy of 0.4. So we're going to take this small fraction over here, which we've been calling R, right? So basically the weight fraction of cementite is going to be R over this, which we called S, right? So this whole distance here, R plus S. So if we convert that into compositions, R is going to be C naught minus C alpha, right? So this is C naught, you can see, and then this is C alpha, so it's just the difference of those two. And then the total length is going to be this composition of C Fe3C minus the other endpoint C alpha. So if we put some numbers behind that, C naught is 0.4%, right? That's the alloy over here, minus C alpha, which was 0.022 weight percent. All of these are weight percent carbon. And then this is 6.7. And then we subtract 0.022 again. And so if we plug all of those into a calculator and calculate that, we will get that this is 0.057. And so this is a fraction of carbon that we have in this amount. And so we can multiply that by 100, which would give us the percent, right? So this is 5.7% weight percent cementite. Or since we're dealing with 100 grams, it's also 5.7 grams of cementite. So because we kind of know that we have 100 grams, the weight percent and the number of grams of cementite is going to be the same. So that's part B, right? We're looking for the amount of cementite that's present in this alloy. All right, so for the next part, it wants us to calculate the amount of perlite, which we know not to be a phase, but a mixture of phases, and the amount of pro-eutectoid ferrite. All right, so let's look at C then now. I'll switch back colors. So C was looking for the amount of perlite, so the weight fraction of perlite and a weight fraction of pro-eutectoid, if I can spell it, ferrite. So here I just want to kind of go back to this diagram here, right? So as we kind of showed in the previous module, the structure of this is grains of gamma, right? All of these are grains of gamma. And then in this region, we form alpha. And at the very end of this, and let me do this in another color, right? Just above the eutectoid, so this green line that's a little hard to see, but that green line just above the eutectoid is where we have the max amount of this pro-eutectoid ferrite, right? Because it forms above the eutectoid. And so if we want to determine the amount of pro-eutectoid ferrite, we can use a lever rule just above the eutectoid of 727. So we can do that here. And so let me blow this up a little bit just so that you can. So I'm just going to show this region a little bit better, hopefully. So that's this point. This is 0.76. This is our alloy of 0.4. And then we're going just above the eutectoid. So we're talking about this line here. And so we'll call this section X for a change. And then we'll call this Y, just to change it up a little bit. So our amount of the pro-eutectoid ferrite, so I'll just, instead of listing this out, I'll just put this little dash here. So this is going to be, this is alpha here, this is gamma over here. So those are the compositions on either side. And so if I want to get the amount of alpha, which is on this side, I'm going to take the opposite. So I'm going to look at Y. So that means Y over X plus Y. And then the remainder, which would be gamma, would be X over X plus Y, right? And so if I put numbers to this, or compositions to start with, so over here, for Y, this is going to be the composition of the eutectoid. So I'll call that perlite. And then divided by, subtracted, and we're going to subtract from it this alloy composition C naught over the same perlite composition minus C alpha, which is over here, right? This is C alpha, this is C perlite right here, and then this is C naught. All right. And again, if I wanted to do the other, I could go through the same methodology, but it would also, they both should add together to be one. So I'm going to just go ahead and plug this one in. So this should be 0.76 minus 0.4, the alloy, and then 0.76 minus 0.022. And so if I plug all of those in, just like I've done before, plugging in all of these amounts, I will get, what should this be? This would be 0.488. So 48.8%. And so then if I do the same thing for this one, it should be 0.512 for the remaining amount of gamma, because I would have X, which would be C naught minus C alpha over the same thing that we had here, right? So the reason this is all important is because we know that this is just above eutectoid, and we know that this amount of gamma at the eutectoid goes to perlite, that eutectoid mixture, and so this is just below the eutectoid. And so if I calculate this, it means if I calculate the amount of gamma, it means I also know the amount of perlite below eutectoid. And so my amount of perlite is 0.512, or since we're talking about 100 grams, it means 51.2 grams. And then my amount of pro-eutectoid, if I can spell it correctly again, ferrite, is the same, right? It's up here. It's what we calculated up here as 0.488. So that is 0.488. That hasn't changed, or that is 48.8 grams. And again, those should be, as long as I did that correctly, should add up to 100 grams, right? So these are the amounts, and I was mainly looking, in this question at least, for, it was asking for both of them, right? So we can give both of them here, the amount of perlite and the amount of proeutectoid ferrite. So again, this is a similar question to something we've asked in the eutectic system, and it relies on things that go through this eutectoid or the eutectic reaction are very similar, and so we can calculate that amount of perlite and eutectoid ferrite.